Okay, hi everyone. Thanks for coming to my presentation. So I know the title is very long, so let's see where these multi-perspective and association rules came from. Process analytics in general, including process mining techniques, we're trying to find more perspective, insights about what is going on, why events are correlated together, why there is a process variance. We're trying to do more root cause analysis. And all of this is happening over the event log, and event log is a very rich data set. That the event log have information about the control flow, so we have the information about what are the activities, the relations, when they happen, so we have also the temporal ordering. And also we have other perspective like the resource perspective, location perspective. In general, it's an event context data perspective. And from here we had the multi-perspective analysis. We are trying to find is exactly how the relation between the changes over the control flow affecting and impact the changing behavior over the data analysis or the data object perspectives we have over the log. To target this, we proposed a multi-perspective analysis technique that's basically using association rules to understand the data connection between the changing over the control flow and the data object behaviors. Event log rule minor, it's our proposed technique, and it's a method more or less that's basically inspired by the knowledge data discovery process, where we have a pre-processing, preparing the data for our analysis to align with the process analyst perspective, and then we have a transformation where we're trying to build out the transactions that can be used to be minded and have the business rule or the association rules from them. And later we have a post-analysis. To go with each of the steps, the pre-processing, we can divide our logs doing a partitioning, so we can have a process drift analysis, and also we can have a variance analysis over our log. So for instance, this log is an example. We trying to partitioning the log based on the cases that occurred in June and the ones occurred in July. So we have two partitions. Then our the goal of the transaction table is to sustain the control flow, the changes over the control flow, and the changes over the data objects. And for the data perspective, we have two basic views. Is the atomic view, where we just focus on each and separate event context, or with a complex one, which is trying to find a correlation between the data context or the event attributes. So basically, if we have our log, we started, the first one is maintaining the control flow using a sequence of two events, and then we're trying out with the different atomic perspective, where we have each attribute we do, like resource, type, and supervisor, and then we have another one, the complex, where we have an actual correlation between these two attributes because they use the same data pool, or they coming from the same data pool. Then we're trying to have a different view over the control flow item to represent the transaction. We have the direct follower relation between the events represented as a case, and then we're using this, for example, for application submit and review application. That's our control aspect. And then we have to check how the resources changed, how the type changed over them, how supervisor, and then how the complex view between resource and supervisor is changing. So as you can see here, the only things that didn't change and have equality is the type. Everything else is different. Doing the same for every event in the first case, we also can have another perspective over the control flow when we have a decision attributes, like the analysts are more interested about events grouping when we have the same resources, like what are the activities executed by the same resource, how the other data are changing. So focusing on this, we see, for instance, in the first case, we have review application and send notification occurred by the same resource, resource 1. So we try to test the rest. We have the same type, same supervisor, but the relation over the complex view is not the same. We are more interested than in mining the association rules, and the rules we are interested in the one that's maintain the control flow in the antecedent and the change over the resources or the data objects as a consequence. So from this transaction table, we generated all the possible association rules where the rule is only 3 items, as you can see. For just an example to explain it, we have a rule to describe the relation between a review application and accept application. When they're happening, they have the same supervisor and resource. Then for the post analysis, we proposed 3 techniques we can use to try to understand or handle the rules. The first one is ranking using the known and existed association rules measures like support, where it's just telling you the percentage of supporting of this rule over the whole transactions. Confidence, which is basically the probability of A given B, so the probability of these rules to be confidently executed when you have the antecedent. And the left is the interestingness measure, a well-known one, which is trying the probability of the rule given the joint probability of the antecedent and the consequence. Then the second technique we propose is combining the rules, and we have 3 templates to try to combine the rule to reduce their numbers. The first one, where we focus on the control flow, and at this point, everything on the consequences is in an AND relation, so all of them has to be true, so this rule will be supported by the log. The second one is a data object perspective, where we care about the change from the data, like when the resources are not equal, what are the control flow or which event sequences can lead to this type of change over the resource. And in this case, all the antecedents will be in an OR relation. And the last one, to really reduce the number of the generated rules, we combined both sides. We combined the antecedents and the consequences. Then the last technique we have is to compare and to do a comparison between the different rules we have. We initially, in the pre-step, we have to divide the log in some partitions. And to compare, we follow and use the set operation, union, intersect, and difference, basically to try to understand what are the most common rules that apply through the log, what are the rules that's unique for this partition and not applied for the others. To evaluate our method, we do an exploratory study that's just to understand if it will provide some insights or not. So the first experiment, we do a pattern analysis. We try to understand why some events are correlated together. If there is some information on the data objects can lead to this event correlation. And we found in PPI 2017, which is covering 3 sub-processes, application, workflow, and offer, that 14% of the cases of the events we have are following rule 1, and that only justify the correlation between these 2 types of events. And that will help if we know this rule and we have or applied this business rule over uncorrelated log, that will increase the possibility of knowing the correlation or finding a better accuracy by 14%. The second rule also show us a pattern where how the 2 sub-processes, the application complete activity, which is a part of the application sub-process, and the workflow valid application are actually related or interacted from the resource perspective, where they have to be done by the same resource. The second experiment, it was basically about process draft over PPI 2020, where we have the log covering cases in 2017 and cases in 2018. And using this, we divided the log in 2 partitions. And then we analyzed it. We wanted to try to understand and find insights if some rules are applied in 2017, not applied in 2018, and vice versa. And we found that the first rule, where we have a permanent approved by administration and permanent approved by budget owner, and they have the same resource, but there is a difference over the organization role for them. This rule is applied 24% over the cases in 2018, but it's never applied over 2017. And the second rule, where we have the permanent approved by supervisor and permanent final approved by the director, and they have the same organizational entity and the permanent organization entity, that doesn't exist in 2018, not applied there. Then the last experiment, we tried to have a variance analysis over the traffic log. The traffic log is one of the interested log because it has 150,370 cases. And the interesting thing is that some cases is taking 11 years, others is taking 1 month, even less, a week or something. So it was interesting to know what is happening over the short cases and what's happening over the long cases. So we selected the cases with the shortest time, 10 to maximum 1 month, and the longest cases from 3 years on. And we do a variance analysis over these two partitions, and we found that one of the things we noticed that most of the activities are executing in the longest cases with different resources and different notification type, like in Rule 1. Unlike in the shortest cases, they tend to use the similar resources and similar notification types. And that somehow provide us insights to understand why these events are correlated together, and also understanding more why there was a variance in the cycle time. So to conclude up, we proposed a method, a multi-perspective analysis method, to provide insights about the relation of changes over the control flow and how that's impact the changes over the data. For a future work, it's more interested how to measure the interestness and the impact of the rules and the dominance of the rules over the data and the separation probability of them, and also to find a better correlation patterns within the data for the rules, and also the visualization techniques, a better visualization techniques to visualize the association rules from a process mining perspective. So thanks for your attention. It was, I think, so quick.
Yeah, thank you very much, Dina. Questions? And we have plenty of time. Everyone has to ask one. No.
Yeah, Dina, thank you very much for your talk. I'm now looking with a BPMN perspective on your talk. And then I was like thinking you are producing a nice BPMN model with like data objects and association between the tasks, but it was different. And then I was like thinking resources, data objects, how is this related? Yeah, maybe you can explain a little bit what are the differences in your work.
So basically, I'm not sure. Can you hear me? Can you hear me? Okay. Okay, maybe I just need to bring it. The idea is, I know that BPMN, we can put the resources in the data objects, but this doesn't actually directly reflect on what happened in the event log perspective. I'm coming from the event log, not from the modeling of the PPMN and the execution or the automation of the process. Like we have PPMN2 where it's supporting to put the resources, data objects, connecting with all of this, what are the data sources. But from the event, we have all of these data, but to do a root cause analysis, normally, if you run a root cause analysis, you will find, okay, we have this control flow perspective, but nothing about how these control flow impact the changes, or maybe justified through the changes over the resources. That's where I'm coming from, basically. It's trying to understand the control flow, or what it was modeled in the PPMN, and even the resources. If the resources say there is a compliance rule that's, okay, these two activities executed by this role, or this resource, or connected to this specific data object, also how that's changed and how that existed on the reality in the event log. So I'm coming from the data perspective more than from the PPMN a little bit. Thanks for your question. Oh, sorry.
Thank you very much. It's been a really nice presentation. Coming from the constraint world, so you have a set of rules, but not all rules are flat. Some affect more than others. And I guess there's some notion of domination here involved. So I was wondering, when you are, because in the experiments that you were presenting basically two rules that they were more or less affecting the same. I was wondering whether you're considering some kind of a hierarchies of rules or chains of rules that are connecting with each other.
Actually, that was a part of our future work, and that's basically what I'm searching for now, is to define the dominance of a rule, because it's not an easy. Till now, we're using the known measures to rank and understand the interestness, like using the left. But I'm more interested in defining another way to define the dominance of a rule, especially for the separation of the separation power of a rule over the events. How it's really showing and starting to separate or justify the correlation between events.
Thank you very much.
Thanks for your comment.
Thank you. Maybe also in this line, so you use association rules, and there are already like existing approaches that do rule mining, for example, declare or all these things. So why was your decision then to come up with the association rules here, and what's the difference, and what you can say more than these existing approaches? Maybe to give us some...
Yeah, the idea is like if you check on data mining, association rules is well-known data models for business process, business rules in general. That's the standard in data mining. Declare rules are more intent to show the control flow information, like over the control flow. And I was interested more in the root cause of the relation of these two events. Yeah, these two events are correlated, but why? What is over the data perspective is happening? It's like how they changing? Are they statically, like if this attribute is always have the same value over the case, or no, it's a changing, something triggers a change. Like for instance, in 2017, you will find that there is one event that actually trigger a whole correlation attribute, which is create offer, and that's correlate a set of events using event offer ID, which is coming from event ID, something like this. While the rest of the events are not having the same characteristics. So I was interested in knowing how to really justify this correlation.
And are you only looking at, let's say, intra-case features, or also in between the cases? So there could be also resources, for example, there could be activities that share resources or something. Yeah, it could be also interesting to find out something like this, so in this inter-case stuff. So is this also applicable, or did you apply it, or?
Unfortunately, I didn't apply it, but it's a very interesting comment. I will do
Thank
that
you.
for my future. It's a part of the current research. Like now we're focusing on trying to find the dominance measure, and maybe we're trying to find this, also understand the interrelation between the cases. Yes.
Okay.
Thank you for your comment.
Sure. More questions? Yeah.
Just one small question, or two small questions to clarify something. First of all, in realistic event logs, it often happens that payloads of different activities are actually not the same. So one activity has attributes ABC, the other has XYZ. Does this matter in your approach at all, or how do you handle that?
So if the totally like different attributes, then they will show in the transaction table. And the other ones, like, okay, if this activity A and B are executed, and we have attribute 1, 2, 3, and there is 4, 5, 6. A is executing 1, 2, 3. B is executing 4, 5, 6. Then there will be a not, and if it's none, then it's empty. Then it won't be considered as a part of the transaction, because we more focus on the changing. If actually it's a pattern, we have to define that, okay, that wasn't defined for instance on A, but when B executed, it start to be defined. So later on it's on C defined or things like this, then that's a pattern we are interested in.
Okay, thank you. And the second thing I wanted to ask about was, do you also distinguish between data attributes that are related to different data objects? Because in practice you would, if you have a domain expert, you would have some information about, okay, this data attribute relates to this data object, this one to a different one. So you kind of would have sets of attributes in a way forming. Meanwhile, you would also have some attributes that are unrelated to any data objects at all. So, I don't know, activity lifecycle transition, for example, which you find in event logs, but it is about the event and not the data attribute or a data object itself. So do you distinguish those as well?
I would say partially, because we allow the user, like the process analyst, to select which are the interesting attributes to do the analysis for. Like, for instance, if you check the transaction table, it doesn't contain timestamp because it wasn't interesting to see the changing from this perspective. I mean, I stored it directly in the control flow with the perspective of a temporal order. So if this attribute is not interested for the analysis, then you just don't include it in the analysis for now. But the grouping, not yet. Like this kind of, okay, that attribute is from object 1 and this is from object 2, and the changing over this, not directly implemented now.
Okay, thank you very much.
Thanks for your comment.
There's more questions. Very good. Sure, there's a not.
So thank you, Dina, for the very nice talk. So we are also looking into analysis of interaction data with association rules. We always have the challenge that process mining techniques, they always tend to have this global look. So the control flow, usually the interest is more on patterns that cover the whole process. And when you look at the data, you change perspective, you have these local patterns. So I wonder if you have also faced this challenge, and if you can elaborate a little bit on how to combine these patterns that have, let's say, different perspectives or views on the same process in the end.
Yeah, we in the beginning we always have that, like, okay, that the control flow is the dominant perspective, and the data is changing, and sometimes the data, when it's a log, like on the traffic log, for instance, there is a lot of variances, and it's covering from 2000 till 2013, so it's also too much. So the process is changing, and the reason where we go to a pre-processing step where we partition the log to have a better understanding, or try to go a little bit local on, okay, let's focus on that variant and how the changes over the variant is happening. That was a way to try to handle this perspective, because yeah, the control flow is always having a very overview of what's happening over the activity side, but not over the data side. Yes. Thanks.
Okay. Are there more questions? If not, then let's thank Dina again.
Thanks to you.